Let me give you a very brief introduction and then I'll give
Okay,
hand over
sure,
the
sure,
floor.
sure. Fine, fine, fine.
So, thank you all. Thank you to all participants who have joined this workshop session. And so, basically, this is a series of workshops that we will be doing. Today is the first session, and we will have the upcoming sessions. Let me share the flyers as well. So, for today, I hope you can see my screen. Today, we have Mr. Orgodev Mukherjee, Mr. Shayok Roy, and Mr. Devjit Das. They are the past winners of this competition. In fact, they are the defending champions, you can say. So we have asked them to give you a guidance on how the overall competition works and what are the things that you need to keep in mind, and overall they will give you a very good guidance, I'm sure. So this is the first session that we are organizing, and then next Monday we have another session, which is another important one because there the jury will be present and they will be clearing all your doubts. They will help you, understand the problem statement and all. So that is for next Monday. And after that, next Tuesday we have another very important thing, which is the workshop on heat load calculations using the E20 form. This is very important. Again, Mr. Ramesh Karthik, who is currently an R&D engineer in Blue Star, and he's also been a winner of this competition, National Student Design Competition. So he will be taking you through the nitty gritties of how to calculate the heat load using the E20 form, which is an Excel file basically. So he will help you through that. So these are the initially three sessions that we have planned, and then after Diwali we will have two or three more sessions. One will be most probably on the AutoCAD, and then one more session we will have another team. So we are yet to plan, but we will let you know once those are planned. But coming back to today's session, we welcome Orgodeep, Shayok, and Devjit. Now, it's very special because they were the participants of last year, and then they became champions. Now they have joined. They are working professionals, and now today they have joined back being an expert. So that really gives a lot of pleasure for Ishrae. That is how Ishrae wants to see um, the ladder in which our past students will walk in their life. So we welcome all three of you, and now I will hand over the podium to you. But before that, a very brief housekeeping that we all should keep in mind. Don't unmute yourself. No need to switch on the videos because that will eat away a lot of bandwidth. So, and please ask your questions in the chat, or you can ask them later uh, in the question answer session also. So that's up to the speakers how they want to take up the questions. But I hand over the podium to Devjit and the rest of the team.
Thank you very much, Shubham, for the warm introduction. So let me share my screen first. Then I think we can proceed with the session. Is my screen visible?
Yes, sir. It's visible.
Oh, okay. So hello everyone. So as we know that there is this NSDC competition is right in front of us. So we're just here to give you an overall guidance of how we tackled it and how you can tackle it. It's definitely up to you, if you go through our path or you can take a separate path altogether. So this is just our view of how students should tackle this NSDC or National Student Design Competition problem. So in introducing ourselves, Yeah. So we are. So I am Devjit Das.
Excuse me.
Hello.
Can you just allow
Recording in progress.
Shayok to into the meeting? I think he's trying to enter.
Shayok, no, he's not in the waiting room.
Okay, okay,
But anyway, once he joins, we are keeping on admitting people, so should not be a
O-
problem. I don't know.
okay, okay. Sure, sure.
So I am Devjit Das. I'm currently working as an associate engineer at Airbus. I and along with my teammate Shayok Rai, who is a GET in Varrock right now. So he is situated in Aurangabad, and I and Orgodeep both are situated in Bangalore right now. And as a matter of fact, Orgodeep is literally in the next room to me. So we are roommates here as well. So
Hello,
yeah.
guys. I am Orgodi Mukherjee. I am also an associate engineer at Airbus, working at Airbus in Bangalore. Yeah, Devjit, you can continue.
So I think Shayok have not joined yet because I think he's late from his work. So I think he would join in a couple of minutes as well. So let us proceed with the presentation. So right now, the question is, what is NSDC all about? So it's a very easy question. Nothing much to worry about it. Basically, you are given a problem. So you have to solve the problem and you have to make the PPT. Then the next step is you are a winner. That's all. That's all NSDC is all about. And so, yeah, I think that's all
Come on,
from
I'm
our
sure
side.
it's not that easy.
So yeah, like no, that's all from our side. So any questions from any of the participants?
Any questions, guys? Uh, I think we covered. I think every aspect of
Yeah,
NSDC
it's
in the past 1 hour session that we took.
hmm.
I don't think so. People have missed any nitty gritty details. Uh, in the next slide, we'll be sharing our socials so that you can follow us over there. Uh, and that's the end of the presentation.
Okay. So if you do not have any questions, maybe we can have. So okay, the this can be a tricky question that how to solve the problem. So any idea of about how to solve the problem? Anyone from the participants? Okay, so no one has any idea about it. Very easy. That you have to figure out. That's all. Okay, okay. No, this should not go like this. Okay, students are already bored, maybe. Fine. Let us guide you through about how we tackle our problem. So yeah, again, what is NSDC all about? So basically, back in our time, or in generic, NSDC have these 9 headers that you need to tackle. First is the CAD drawing. There is the heat load calculation. Then you have to select the equipment, like through which you would be, maintaining your certain air conditioning levels and all. Then the energy calculations. For example, how much would the AC bill or how much would the air purifier bill? This watt hour calculations would be there. Then there is design qualifying and load fluctuations. So you need to design in correspond with the load fluctuations. Then there is life cycle cost analysis, originality of your like solution. Then the practicality. So you cannot throw away just a imaginary thing like we would have a quantum arc generator or something like that. That can't be there. So you have to show the practicality of it. And finally, the I would say the tip of the iceberg is innovation. So what makes your innovation or what makes your design, better than others, or why the your the judges would select your idea. So the innovation is a very key parameter to decide that. Now, I think in your case, I think the CAD drawing is already given, so you don't need to worry about this one. So we are giving you an overall of what we have done in the past year. So basically, the NSDC 2023 problem statement was that you have to design, we have to design the air conditioning system for a five-star hotel in the coastal area. But our case, the problem, or rather, the problem statement was, oh, I think Shayok has joined.
I think Shayok is amidst us. So, hello, Shayok. Uh,
Hi Shayok, welcome and thank you for joining this session. This is
Yeah,
Shubham
sorry for being
from
late. It
Ishrae
was,
Kolkata. No
anyways.
problem. Yeah, welcome, welcome.
So yeah, so our problem statement was how to design a air conditioning system for a five-star hotel in coastal area. Now, one of the key things that we would like to mention is back in our time, the file, like the AutoCAD file or the layout was not given to us. So we had to create it from scratch, and we would show the whole procedure in upcoming slides. So I think you can get an idea from that. So the aspects we kept in mind was the site analysis and orientation, like how, like where exactly the where exactly the site would be located. Then the second factor was building massing and shape, like what would be the shape of the building, so that I would get the maximum amount of efficiency and the minimum amount of heat infiltration and everything.
I would like to
So
add on to
then,
that point as well. Building massing is, uh, the bricks that people use in a building also determines has an effect on the HVAC calculations. So there are different bricks, okay, which have different porosities, and uh, based on that, the heat transfer coefficient of the here bricks is affected. And also based on the porosity, the mass of the bricks also depends. So the building massing is an important analysis and calculation, and in determining, what type of material is used to make the building. Yeah, Devjit, you can continue.
yeah, sure. Thanks, Arvind, for the add-on. Then the guest room placements. So as we didn't have the AutoCAD drawings with us, so we have to place the guest rooms as well. Amenities placements, like for example, where would the restaurants be situated? Where would the maybe game rooms or gyms or the lavatories, etc., would be placed? Everything we have considered back then. The banquet halls as well. The structural considerations are also kept in mind. The accessibility and the circulation, the safety emergency, and like for example, if there is a fire breakout in the whole hotel, so what would be the path? So you cannot take a lift at the time of any kind of fire emergency or something like that. So we have kept that in mind as well. Then obviously sustainable design, you all know that what sustainability means, and like how important that is in the current scenario. Then landscaping and outdoor spaces. So you don't want a room that is maybe that is not having a outdoor view or proper view outside. So yeah, that we have, like for example, if you are going to a five-star hotel, right? So you are paying maybe more than 20,000 a day, or maybe even way beyond than that. So you don't want a very bland room or something like that. So we have to keep that in mind as well. Enhanced soundproofing, you know what that means. And finally, integration with local culture. So this is something we had an add-on. We tried to have an add-on so that the kind of the thing doesn't seem out of place of the zone we are or the site we are located that in.
I would like to add something to this to this slide as well. So when we talk about guest room placement, amenities placement, banquet halls, structural conditions, you have to understand that five-star hotel, which we were asked to make, we were given some conditions. So there needed to be, I think, 80 rooms of specific size. There needed to be club rooms, there needed to be games rooms, and you can't just make a room out of anything, and you can't just size the room uh, having any number in your mind. So there needs to be a standard that needs to be followed when you are making a hotel. So there is a standard called NBA standard, uh, which gives us a brief understanding of how to design a building. Okay, So when we looked through NBA standard for hotels, we got a brief understanding of, let's say, if we are to make a guest room or a club room or an exquisite suite room, uh, something like that, there needs to be variations within those rooms. Okay, it cannot be like every room is the same, because uh, the cost of running or cost of the person paying for a better room, he should be able to enjoy something which is, uh, an enhanced experience in a five-star hotel, right? So that needed to be taken under consideration. Then there were three banquet halls. I think one was of capacity 2,000, one was 1,000, another was 500.
Yes, yes.
So when you are designing a banquet hall, what you need to understand is, yes, this last point, enhanced soundproofing. So banquet halls are meant for varied load capacities, because a lot of people will be present in a banquet hall, and based on the event that is being organized in the banquet hall, the heat load might vary, right? So there might be a full-on concert going on in the banquet hall. Maybe there is a, you know, some kind of TED talk which might be going on in the banquet hall, or some kind of marriage ceremony that is going on, something like that. So based on various conditions or various uh, loads, you have to think of or forecast something which, so that the amount of people, they can be comfortable inside that banquet halls, right? Also, Devjit was talking about escape during fires. So banquet hall is a very big choke point during these fire hazards, because there are a lot of souls inside a banquet hall, and if the banquet hall is not properly designed with respect to these conditions kept in mind, there might be, you know fatalities, and people might die in those incidents. So you have to also think about, the if there is a fire breakout, a person must not be required to move more than, let's say, a certain amount of distance, let's say 50 meters, uh, 10 meters or 15 meters, before which he can encounter a exit door or a stairwell which leads him down into the bay area of the hotel, so that his evacuation is quick and it's easy, and there is least amount of fatalities. Okay, so these are some kind of thought process behind uh, building or designing a banquet hall, guest rooms, amenity placements. So amenity placements, like, let's say, if you're talking about gyms, if you're talking about home theaters, uh, then a five-star hotel also has a lot of sauna rooms. Uh, then there are indoor, maybe courts, swimming pools. So you have to think about a lot of different amenities that are required, and when you're designing, you have to think about so many things. So that is some brownie points or points to think about when you are designing something. It's not like uh, nothing can happen just like that. There are a lot of thought that goes behind designing something. Yeah, deeply. I think you can move on to the next slide.
Yeah, yeah, sure. Thanks, Arvo. Yeah. So this is all about the aspects we kept in mind back while designing. So as I have already mentioned that we were not given the CAD models back then or CAD files back then. So we created our own five-star hotel layout. Then we calculated and do all the proceedings according to that. So this was the five-star hotel we created. So if we zoom in, We can see, I guess. Yes. Yeah. So this was basically the sea. This is the seashore. There's a kind of private beach we like to mention. Yeah, this is the five-star hotel. I don't recall the exact square feet in area it was, but yeah. So this is basically the ground floor and all the land layout of the five-star hotel. So we considered a open air ceremonial space. For example, if someone wants to conduct a wedding there or any kind of ceremonies or any maybe social gatherings or something like that, or even corporate gatherings that can be done here. There's a children's park and a lake is also there, and we have tried to create a this walking space behind the children's park and lake. This is an open air theater. So this is basically, as you already know, so we are from Jadavpur University. So OAT or open air theater holds know, very grave space in our heart. So we've tried to create an open air theater, and the main funda behind keeping this is, for example, if there is a concert at a maybe corporate gathering or something like that, that can be held here. So apart from that, this is the ground floor. This is a swimming pool, and there are sitting arrangements there. This is, I think, the 2,000 capacity banquet hall, which Orgo was talking about. Okay, this is the lift space. So people would borrow the lift from here. This is the car entrances. I would show the garage and underground parkings as well. This is a restaurant here, and there are multiple. This is the kitchen for the restaurant. There is another restaurant here as well. So this is the ground floor layout. In the first floor, as you can see, this is the
Devjit, I think you
1,000.
can zoom in a lot, zoom in
Okay,
a
okay,
bit
sure,
more
sure.
to clearly show the names of the places.
Okay, okay, sure.
Okay, I think Devjit, would it be
Yeah.
better if I explained it myself, because I think since I worked it on it extensively, it would
Yeah,
be
yeah, sure,
easier for
sure. You
me
can
to
carry.
explain in much more detail. So I don't know if my cursor is visible, but I think I can annotate. Uh, yes, yes. So I'll be annotating with yellow. So this area that you are seeing here, this is the 2,000 capacity banquet hall. This is the stage. Okay, this is the stage. Uh, so what the thought process behind this CAD planning was, the cars would enter from here, and there is a place where the car can go down, and there is a parking space as well. We'll come to that. Next, there is an entrance. So this is as you enter into the building. There are sitting areas here. So you can see that sitting areas. This is the reception. Okay, and there is a as you enter through the building, there is an entrance to the 2,000 capacity banquet hall. This is the stage, and these are chairs and tables that are placed, you know, at sporadically all throughout the banquet. So we are talking about fire emergency exits, right? So you can see right here, Devjit, if it's possible, if you can zoom in a bit more, then I'll be able to show them. Uh, there are various doors, if you guys can see. So these are the doors where okay, annotate annotate, and I think yes, yeah. uh, okay, so these are the doors. and there are stairwells. So these are the stairwells, okay, where people can easily evacuate during an emergency situation. Okay, uh, so there are various gates. Um, Also, when you are talking about a large audience, you have to manage that audience as well. So the audience must not be forced to sit there and just look at the movie or whatever the ceremony is, and not allowed to go use the washrooms. So you have to put washrooms also. So when you're managing the crowd, you have to put various washrooms. So these are washrooms, and also there has to be two types of washrooms, right? So that or instead three types, uh, so that people don't feel left out when they are using washrooms. Okay, so that is also one important thing that you have to keep in mind when designing. This is a much in-depth analysis of what our thought process was behind designing. Since we are not given the CAD layout, we had a lot of ideas which we wanted to showcase in that uh, CAD. Okay, so this is a bar area where people who are interested to have a drink can order drinks here. So you can see that this is a bar area. Uh,
Restaurant cum bar.
yeah, restaurant com bar. So this is a restaurant sitting area. Okay, so there needs to be a kitchen also because you are serving people food. So this is a kitchen area. Okay, behind the bar where the food can come out from here and then be served here. There needs to be also restrooms and washrooms for people. This is a mandatory thing. Okay, and then
Shubham, sorry to interrupt. I think people also can annotate this. Can you stop this? I think this is a bit annoying for us.
Yeah, I don't know how to do it. If you can guide me, where
I
is it?
Okay. Let me find it. If I find it, I would inform you.
There is an option to clear all the annotations that I know.
I think there is an option for disable annotation for others. I think all of you can do that.
Okay, let me.
That
I am not able to. Okay, wait.
three dots more. Click on that.
Okay, no. Where is it? Can you guide me?
In the Zoom screen, top bar, you can find the mode option there.
Zoom screen.
You are finding the mute start video participants, that bar, right?
Yes,
There is a mode option on the rightmost side of it.
I can only see. Wait, I can see notes, whiteboards, apps.
Okay, let me annotate it for you. That
Okay,
is
okay.
all
You
right.
can do that on your end.
Oh,
I'll be
okay,
guiding
fine.
you through. Okay, that
Okay,
would be
sure.
easier.
Yeah, you can carry on.
Okay, so if you can annotate on yeah, a bit higher. Yeah, this is the reception area where all the paperworks needs to be done. Yes, mm, paperwork needs to be done. This is also a larger kitchen. That is supposed to uh, prepare food for any personalized cuisines that people request as room service. Okay, I think that's enough for this layout for the ground floor. If we can move over to the next floors. Uh, for the first floor, yeah, for the first floor, you guys can see that we have a mm, 1,000 capacity banquet hall. Yes. Devjit, yeah. Yeah. So yeah. So on the left hand side of the building, you can see that this is a 1,000 capacity banquet hall. The banquet hall, the stage on the banquet hall is placed so that everyone can get a proper view of whoever is on the stage or performing. There is a dedicated backstage where singers and performers or anyone can use washrooms. Also, you can see that there are washrooms. Okay, on the uh, bottom left side, you can see that there is a bar also. There's a bar to keep people entertained, and they can uh, get drinks or something, or maybe starters or appetizers as they enjoy the show. And on the leftmost side, on the rightmost side, you are able to see that this is again a restaurant. Okay, this is again a restaurant, and this restaurant is having a lavish setting, because this restaurant also has a live stage for live music. Okay, there is a bar that is there. There are different types of sitting arrangements you can see on the left side of the restaurant, and in the middle area of the restaurant. There's of course washrooms for people. There is a kitchen on the top of the restaurant. If you can annotate the kitchen as well. Yes. Uh, yes, the kitchen. Yes, the washrooms and kitchen he has annotated. And on the other side, there is again a smaller restaurant.
This is a fine dining.
Yes, this is for fine dining. So you guys can understand that restaurants are also of different types, right? So some are fine dining, some have live music, some are bars, some have a lively setting, some have a somber setting. So based on that, you have to think of how a restaurant layout happens, and you have to design accordingly. Okay. Uh, in the middle, also you can see a fountain, which is also an aesthetic component to the building. Yes, that's all about our first floor. Uh, we'll move over to the second floor now. Devjit, I think if you can delete all the annotations, yeah. Yes. Uh, yeah. So we have the layout for second to fifth floor. So you can see that there are 20 executive rooms and 20 guest rooms. So we have, as I was telling you in the previous slides, that all room can't be the same. So there needs to be difference in the size of the room, the view from the room that the person is getting. Also, the person needs to have an experience which is different for every penny that he's shelling out of his pocket, right? So on the top side, you can see that there are the executive rooms. These are the executive rooms, and we planned to have them at a higher price than guest rooms, and they will have the sea facing view. Okay. And the rooms that Devjit has annotated as yellow, they are the guest rooms. Yes. And you can see that the size of the guest rooms are a bit smaller, and there is only one bed in the guest rooms, and the executive rooms have two beds. And the size of the washrooms are also different. There is a balcony. The size of balcony is different. Uh, there are a lot of other details which I am sure uh, have not been captured as screenshots, but yes, yeah. So these are a detailed view of you can see the beds, carpets, various uh, sofas, washrooms. There's a countertop on the left side. Yes, and there is a balcony where there is sitting areas on the balconies. So for every small detail you place in the room, you have to at least have a standard which you refer to, which I already talked about, which is the NBA. And also you have to think about the user experience also. For the person who is paying the price and having an experience at a 5-star hotel, I am sure that most of you have not had like 5-star hotel staying experience. It's a rarity in India at least. Uh, so uh, so these were the layouts for floors 2 to 5. Uh, when you can move over to sixth floor, on the sixth floor also we have what we call I think club rooms, right? Like luxury suite rooms. Yes, we were talking about suite rooms. So you can see this luxury suite rooms are even larger. So even more amenities and uh, luxury is there for these rooms. Um, I'm not going to describe every small detail in this rooms for every other room. Yeah, on the left hand side of the building, you can see that there is a restaurant that caters to having a brilliant view from the sixth floor. Uh, on the sea facing side, there is also a sitting area. You can see. What Devjit is annotating is escape route, escape plan. Yes, exit routes. Yes, there's also washrooms and kitchen areas. And on the sea facing side, you can see that there is some sort of greenery that is there, and also sitting areas. You can have a great view of the sea from the sixth floor.
To add to Orgodip, that top left corner was it would have been the lounge room, which would be sea facing, and it was like a rooftop sea facing place where people just could sit and hang out. When with we added some trees and chairs to improve the aesthetics, and in the next in the next floors there were the club rooms and the yoga rooms, which David would show. Yeah, so in this room we had gym facilities, we had a we had a yoga room, and we also had a games room where there were billiards tables and everything. So, and we had some few luxury suite rooms as well, and there was a rooftop terrace.
And spa as well.
So all those things which you see, that as the club rooms, game room, yoga room, spa, different types of restaurants, different types of rooms, all of these things you have to keep in mind while designing the a hotel. So when you plan the hotel layout, like you will always there are some things which you have to keep in mind, like the luxury suite rooms or the rooms which are priced at a high, which are kept at a higher price. They should the people who are staying there should have a should have a good experience. So their rooms must be filled with must be having better amenities. So these rooms are placed near the other rooms, such as the club rooms, games room, and the spa and the gym, etc. Now you have the underground levels, which is the car parking zone. The in the ground floor plan where Orgodip showed that there was a spiral like place from where the cars could go down. The cars would be that spiral is also being presented here, and from there the cars would enter into this underground car parking levels. We have 3 underground levels: -1, -2, and -3. So some all of these things which we did not decided on our own that we would be we would have so and so guest rooms, we would have so and so luxury rooms, and we would have so and so executive suite rooms, or 3 levels of underground parking, or all these facilities. Some of these were given to us as objectives from Ishrae, that the hotel layout must have some these and these features. So we had to incorporate them. So it was not entirely done out of on a whim. So there will be some even in your even when you guys participate in the competition, when you will, I don't know if you will be given the AutoCAD layouts or not. If you were given the AutoCAD layout, they're identified. If it's not, they will mention some prerequisites that you cannot give any design you want. The design must contain some certain features for it to qualify as a design. So you have to keep those in mind, and then after incorporating those things, you can add anything which you want to do. So after those, those were the 3D models. So those were the 2D AutoCAD files, and now we move on to the 3D models. So you can see this was the front view and the rear view of our hotel. We designed this 3D model using eQuest, which is a software which is also used for energy load calculations, which you see further down the slides. Now it comes to the most important part of the project, which is the heat load calculations. So now, once you have designed the hotels, kept in mind of all the aesthetics, now it comes to the engineering part. So in the heat load calculations, it can be subdivided into various categories. So heat which enters into the building, it can enter via due to various reasons. We have heat transfer due to opaque surfaces, heat transfer due to via transparent surfaces, due to air infiltrations, due to electrical equipments, as well as the occupants inside. You can see there are some formulas present here which relates to those categories. You can find more details about them when you browse through the internet. And also you have to keep all those factors in mind when you choose all the installations inside the hotel. So, for example, if I am choosing for example, when you are choosing a hotel, you have to keep in mind what sort of bricks you are using, what is the thickness of the bricks, what sort of plasters, and what sort of paint you are using on the outside. Some colors reflect light more, some colors absorb light more. So as a result, their heat absorption and reflection coefficients will be different. So it all depends upon, there is a certain value known as the U value. So you have to keep in mind the U value of all those particular installations which you keep inside the hotel. So moving on to the next slide. So we used a software known as the hourly analysis program, which is a software made by Carrier. It is an industrial graded software which is used for heat load calculations of various multiplexes, and we use that software and to generate heat calculation reports. You can see a sample report, which it's actually a screenshot from one of the pages. The entire report for the entire hotel was about I don't remember the exact number, but it was like 30 to 40 pages. So
yeah, and we did this report for every setting. You can see that this is a report only for the, I think, 2 to the 5th floor, floors 2 to 5. So we did this calculations for the ground floor, first floor, floors 2 to 5, 6th floor, 7th floor, as well as the underground levels as well. So cumulatively, it was I think 120, more than that, 200-page report that we had got from our early analysis program software. And out of that, this is just one screenshot of the of the air system sizing summary for floors 2 to 5. We thought of placing this because the majority of the people staying at the hotel will be in these floors, right? So you can get an example of what the values are like. I think Shayok will go through the values once.
So you can see that we have chosen some air system information, and the air system name is, as you know, is floor 225. And from Shivaji Kale, HAP is a paid software, but you can
We
get
had
it for free
actually
from
we had got the
various.
software from the professors at Jadavpur University. We had got the our professors were actually instrumental in handing us that software, and it had been quite a help from them. Yes, Shayok, you
Yeah,
can continue with the information on the sizing. Yeah.
yeah. So you can see that the air system sizing summary, you can see that there are a number of zones for which is 41. So what is a zone? If you go back to the floor, if you look back to the floor plan, you will see that for each of the floor, there were a number of rooms. Devjit, can you move back to the floor plan? Yeah, so in the second and fifth floor, you can see there are a number of executive rooms and guest rooms. So each of these executive rooms and guest rooms was a zone, and along with that, the corridor. So 20 executive rooms, 20 guest rooms, and the corridor, they make total 41 zones. That was the number there. For calculating the heat load of all the different floors, you have to separate the floor layout into specific zones. So, in the 2 to 5 floor, each of the floors had 41 zones. The floor area, and we had chosen Chennai as the location because it was the sea facing, because the condition was it should be a tropical location facing the sea. And the air system type is VAV. VAV stands for variable air volume. Variable air volume is a HVAC system where the temperature and the airflow is automatically adjusted. And it is not a constant. And total cooling load which was calculated was came out to be 91.4 tons, which is around 321.4 kilowatts. The supply, so from using these values, and then after calculate and for all the floors and adding on, we got around a subtotal of around 1280 tons, which is around 4500 kilowatts. So using this value 4500 kilowatt, we had to choose our HVAC system components. So moving on to the next slide, where we went on to choose air system components. There is also one thing you should keep in mind while designing choosing the air system components. You have to choose the dimensions of the ducts connecting all those components. So there are various methods of calculating the duct sizes. We use the equal friction drop method, which is which assumes there is a constant friction loss for all the different types of components, present in a duct. So these are all the various zones which we separated into as, and what are zones I already explained to you. And this was and using the area of the zones, we calculated the duct sizes. The duct dimensions were calculated using this McVay duct sizer software. So in this software, you have to input two things. You can see the flow rate and the head loss. The flow rate can be calculated. The flow rate is can be calculated from the HAP software, that is the hourly analysis program. The flow rate was calculated from that software, and we put that value in this McVay duct sizing software. And then this equal friction head loss. Head loss is we took as 0.386 in water column per 100 feet. It was a standard value which we found from NBA. So using that, you could calculate the duct sizes. So we calculated the duct sizes for each of the different zones, and which we presented here. So moving on to the next slide, you can now see what are the components which we are supposed to which we chose. So two important things which we have to choose when you design an HVAC system is the chillers and the air handling unit. So we already knew that we have around like 4,500 kilowatt, which we saw in the previous slide as the cooling load. So we chose chillers. We chose this chiller having a capacity of 1930 kilowatt, and we selected three of them. And for AHU, we chose we chose this one having an air handling capacity of 2,000 to 125,000 meter cube per hour, and and for the ground floor and the first floor, and for the floors 2 to 7, we used a smaller AHU. Now these, and so how do we came up with these values that 2,000 to 125,000 meter cube per hour would be enough for the ground for these to maintain the floors? These values you can get from the HAP report. Moving on to the next slide, the interior air quality features. So as you know, this special interior air quality features. It was an objective given to us from Ishrae that the hotel which we are designing should contain some special interior air quality features. So what are those? Because since it's a 5-star hotel, and so it will it would have some special features which would cater to the needs of its residents. Though, so there are yeah, there are various ways in which the air quality inside a hotel can deteriorate, which we have listed here. To improve that interior air quality, we suggested the usage of ozone air purifiers. So for ozone air purifiers, so we browse the internet during preparing of this report. We browse the internet. So what are the various things which one can install to improve the air quality? And we found out that ozone air purifiers were one of the best things currently in the market. So we chose that. And to select which ozone air purifier, we have listed the factors: the area to be covered and the CADR, which is the clean air delivery rate. And keeping those things in mind, we chose these three models, and we have listed the features of them as well. And so innovations. Innovations is another important subtopic which was pointed out in the Ishrae brochure, Nsdc brochure, that our design should contain some innovations. So moving on to the next slide, you can see what were the innovations we had put forward.
I think I can carry on from here. Okay.
Yes, please do.
So as we have already mentioned that, so basically we have covered up the requirements of the NSDC problem statement. So right now this is the kind of another feathers on the crown of our presentation. So we started off with the seawater cooling system. So as we all know that the hotel is situated near the coastal area or near the sea. So one thing, while finding out that what could be the possible innovations, we came across with the seawater cooling system. So basically, what happens is, as I believe you are participating in NSCC, so you have a little bit understanding about how refrigeration systems or how air conditioning systems work. So basically, what happens is have a you have a refrigerant. You you circulate that. You get the heat from the room. The refrigerant gets vaporized. Then you pass it through some kind of chiller plant or something, so that you can cool down the refrigerant. You can again make it liquid so that you can carry on the cycle. But we what we tried here is to replace the chiller plant, because as you know that if we are installing a chiller plant, first thing that would it cater to is it would require a new space allocation, and a chiller plant size is not like kind of negligible. So first of all, you need to have a space allocation, and apart from it, you also have some more energy inputs to it. So you have to, kind of, you have to waste energy on it. So this seawater cooling system is a kind of system where you have a seawater intake, and from the seawater is passed through a heat exchanger, and the another side of the heat exchanger is the warm refrigerant, so you can cool down the refrigerant from there. You can pass it on the your heat exchanger in the central air conditioning system, and you can blow the air through it, and all the residents and the whole hotel would be cooled through that air. So as you can see in this diagram right here, this one, I'm sorry, yeah. So in this diagram, you can see the details of it. So this is basically the seawater intake. It goes through this channel. This channel is the heat exchange. This is basically the heat exchanger part, this green one. Then this whole channel is completed. This 7 is the warm fresh water. So the warm fresh water is coming through this. Here the heat exchanging is taking place. This is the warm seawater, and the seawater is not like super warm for the sea creatures. We have to keep that in mind. So we cannot harm the environment for our benefits. So this is also kind of calculated, the amount of heat, like the amount of temperature rise the water can have. And this is the fan. So basically, this is the whole heat or the cooling cycle rather. This is the whole cooling cycle. And this is there are mainly two type of seawater cooling. One is SWAC, that is direct seawater cooling system. So wherever you are having sufficient depth from where you can collect the seawater, so that, and you can already understand that if the depth is higher, the seawater is more cold, or rather you can have a rather cooler seawater from there. And if you are not having that scope, you can use the seawater air conditioning system with auxiliary chiller. So it's not as big as, or it's not as power consuming as like our typical chiller plants, but it's a good kind of replacement to the standard systems we are having. Then moving on to the numbers we had. So as you can see, there are mainly 4 graphs, and they speak for themselves, but still I would walk through them. First is the power consumption. So you are making a 5-star hotel, right? You want to make profit out of it. You're not doing it for any kind of charity or something like that. That is to be very honest. Now, if you reduce the power consumption, that is a huge profit to your margin that you are having. So the conventional normal auxiliary, or sorry, not normal chiller systems would consume around 3,500 kilowatts. Then if you use the SWAC, that is the direct seawater cooling, you can save up to 88%, and that is a huge number you can get. And if you are using the auxiliary chillers as well, you can in that case you would be getting around 47% savings. Then in the capital investment, this is another part to it. So as you can understand that conventional chillers, you don't have to invest that much, because they are already standard systems that are already in market, and there are proper stakeholders for them as well. So you can get it for a very cheaper price. But if you invest in SWAC, and SWAC is auxiliary chiller, the capital investment is a bit on the higher side. But in the life and cost cycle analysis, you can understand that in the long run you would be profitable. Then in the CO2 reduction, that is the sustainability part to it. So SWAC can reduce up to 34 kilo per day of CO2 emissions. That is a very good number, I would say. And last is the
34
payback
tons.
period.
34
Yes,
tons.
right. Sorry. And last is the payback period. So if you are using the SWAC for around 6 years, you are already getting your capital investment back. And for the SWAC with auxiliary chiller, you are having this 3.88 years. That is even faster. So moving on to the second innovation we proposed was the zero energy building. So the idea behind this was that if we can generate the electricity in house, so we don't have to pay for it. First of all, the profit would be higher, and secondly, this is like greater for the nature as well. So here, what we suggested was high insulating spray foam insulation. So as already mentioned about, sorry, Shayok already mentioned about the heat load calculations. So you have the infiltration loads, right? Or the opaque surface heat inputs. So if you are using the proper spray foam insulation, two things would happen. First, that is the sunlight or the heat load you're getting from the sunlight that would reduce. That cannot pass through the bricks inside your building. First thing. And second thing is whatever cooling you are doing inside the building, that is not getting hampered through the environmental features. Second is the high efficiency solar panels. This is self-explanatory. So if you're having solar panels, maybe some kind of solar thermal system or photovoltaic system, you can have the electricity in house at least up to some point. Maybe you're not getting the 100% or power requirement out of it, but you can at least get some portion to it. Then third is the high efficiency heat pumps. This is in regards with the air conditioning system efficiency itself. And last is the highly insulating and low emissivity triple and quadruple glazed windows. This is in contrast with the your heat transfer through transparent surfaces. So if you are having this kind of triple or quadruple glazed windows, they are having, I think, 3 or 4 layers which can block the sun rays. That means you are having the light requirements from it, but you are not having that kind of heat. And this is as we have already mentioned that you have to not. This is not only about uh, making them say that this can be done. We also had to prove that this has already been in function or something like that. So Indira Paryavaran Bhavan, that is located in New Delhi, inaugurated this system, this zero energy building system that is already in function. So that shows the practicality of our innovations. Then moving on to the building management system. So as Shayok already mentioned about the indoor air quality features, I think you have or may not be noticing that the indoor air quality features is the controlled by this building management system. So this is basically, for example, if you have rode the metro rail sometime, I think you definitely have. So you can see that uh, maybe when in puja times or maybe when in you are freezing. So the major thing which I would like to point out is that not every time you require the same amount of cooling load or same amount of cooling rather. So this building management system uses a certain kind of network infrastructure controllers. Controllers are as such in VFD, that is variable frequency drives, so that you can control the level of cooling inside the building. For example, in the banquet hall, if someone has booked for maybe 2,000 people, but the capacity or the filling is up to maybe 1,000, maybe 1,600 or something like that. So in that case, you don't need to cool that in keeping in mind about maybe 2,000 people. So that is the thing which we try to keep here. So the benefits of it is lower energy cost, obviously improved comfort. So people won't feel freezing at some point. increase productivity, increase security, and data collection. Data collection is basically, this whole thing is driven through software. So as you can see in the leftmost side of it, one second, zoom it in. Yeah. So in this BMS whole cycle, this is done through this. First of all, you have this field controllers. So they are mainly controlling all the features of the air conditioning system. This is the input from here is going to communication bars. So you have some sensors there. So they are getting the inputs for you. You are giving them to communication bars. You have the network controllers. That means you are feeding them to somewhere that is up here in the software. And then the downstream or end device, that is the output side of it. So you are having a sensory input, you are calculating the thing in, then you are having in the downstream side, you are having the output. The software is again giving the input to the field controllers, so that you are having a automated, best to comfort building management system. This is the schematic of it. So rooftop, you are having the controllers. Fourth floor, you are having this, and this in the basement here, they are having the chillers, but we don't use the chillers. We're using the seawater cooling there. And so this is basically the walkthrough of how we tackled the problem back in our time. Now, going to this year's, your problem statement is design of air conditioning system for a multi-specialty hospital building that pertains to comfort, cooling, ventilation, indoor air quality. So this is the topic on which you would be working. The parameters won't be the same for you guys. For example, the things we kept in mind may not be useful to you, and vice versa. So some points we kind of chalked out here is the aspects you should keep in mind is occupancy load. Occupancy load means the number of persons, the patients, the nurses, doctors, everyone present there. So it would lead to some kind of loads there. That is the occupancy load. Second is the equipment loads. So you are having n number of equipments in a hospital. So every equipment that is running on electricity, and you all know that nothing is a proper or nothing is a 100% efficient engine or something like that. So everything would generate some kind of heat load from their end. So equipment load is something that you need to keep in mind. Third is the building
MRI
envelope.
scanners, CT
Yeah,
scanners, X-ray machines. These are mainly the main, the machines that
Contributors to
generate a lot of significant heat during operation. Yeah.
Then there is building envelope. So you need to keep in mind everything. For example, from the entry to the exit, everything you need to keep in mind, because it's a hospital. There should be emergency wards, there should be normal wards, there should be surgery rooms. So you need to keep the whole, kind of the flow you need to keep very smooth in case of a hospital. So because it's a matter of life and death. So building envelope you need to keep in mind. Fourth point is ventilation and air exchange. So this is a very important point, because hospitals is more prone to bacterial or fungal growth in the air inside. So you cannot let the air run around the whole hospital. You have to ventilate the air properly, and you have to purify the air as well. So this ventilation air exchange is also something very important. Fifth is sustainable design. This is, I don't think I need to emphasize more on it. Sixth point is airflow design and distribution. So the airflow design that already we have mentioned regarding to the duct sizing and everything. So where would your central cooling system would locate, how the ducts would be designed, how the ducts would be distributed, everything you need to keep in mind. 7th point is VRS versus chilled water system. So I think that this Orgodip can take over later on. 8th point is seasonal variation.
Let me give just I think brief like one liner on VRF and chilled water system.
Yeah, sure.
So chilled water system, what happens in chilled water system is chilled water is used to cool the air inside, right? And for VRF, use variable refrigerant. So refrigerant is used to cool the air inside. So that is the basic difference. So when whether you should use refrigerants to cool the air, or should you use chilled water systems, because uh, hospitals as it is, they need a lot of water in other requirements as well, you know, because like washing of different equipments of that are used, you know,
Surgery
and
equipments.
surgery equipments,
Mm.
water is used for a lot of other functions in a hospital.
So because you
So
need
you,
to maintain the cleanliness there at the peak.
yes, so so if the hospital itself is using a lot of water, you know, it might also abrupt the water situation in the neighborhood in which the hospital is situated. So would it be you know uh, a wise decision to use VRFs in in that case? That is also something you should ponder upon. Yeah.
Hmm. True. Eighth point is the seasonal variation. So I think, for example, in Kolkata. So in Kolkata, in peak summers, you're having a certain kind of heat loads. So you need to maintain the cooling according to that. And similarly in winter, so you're having a large difference there. But for example, in Bangalore, you don't feel that kind of fluctuation is there. So for every locations or every sites on which you are designing the hospital, according to that, the seasonal variations would also take place. So it's not like that you can make a generic hospital design there. So you have to first clarify the location, then you have to go through all the points we have talked about in here, and lastly the regulatory standards. So while designing a hospital, as Orho already mentioned, that we are having a certain kind of regulations for hotel design. So Indian government has also a certain kind of regulations for hospital designs as well. So you need to have this n number of bullet points in a hospital to certify it as a proper hospital, or to get it certified. You cannot have this some parts, oh, okay, this can be done or something like that. So you need to mention the regulatory standards as well in there. So I think you have to work a lot on the topic that you are already given, and this is, I think, a very noble topic, I would say, because while designing a hospital, first of all, you need to keep in very large number of things in mind. And last thing is, I would say that this whole thing should be practical. Try to keep originality to its peak. I know it's hard for you guys. You are just college pass outs, like as we were last year. So I know it's hard for you to maintain that much level of originality, but try to research as much as possible. Try to have proper research papers on them, which are already published. Try to have some proper examples that this is already implemented in here. And in the innovations part, definitely you are free to do anything. So proceeding with it, go for it. Don't get too much frightened from it, that oh no, you have to make a hospital for this small competition. Don't think it in that way. I think you all would be a very good contender. And the last thing from my side would be, uh, don't let your other teams win, because at the end, this is the competition. So if you win, you get a lot of recognition, certifications. So after we won the NSDC competition, we were like the kings at our college, that okay, these guys have won NSDC. So these are like genuinely brilliant students or something like that. I don't know the reality of it. That is a separate story. We three only know. But yeah, you get the recognition, you get the prize, and maybe sometime in future you would be in our chairs, presenting here in front of a number of people, a number of enthusiastic students. So yeah, finally, again, again we have come to the same slide. Now this time, if you are having any questions, yeah, I think we should have some questions right now. So we are free to answer them. It's all yours right now. Go for it.
Yeah, okay, great. So that was an excellent presentation, Bhargav, Devjit, and Shayok. And so, yeah, to all the participants, if you have any questions, this is the right time to ask them. So you can unmute yourself and ask.
And another thing is language is not a barrier. You can ask in Hindi, English, Bangla, whatever. No issue. पाती बांग्ला
Uh,
बोलने को मैं चाहती हूँ.
I had a question that from which part should we start thinking about the competition? Like there are various parts that you have mentioned in the presentation.
The you should, I guess, at first choose the since you have to build a hospital. So I think you should at first try to look at existing hospital layouts or
No, no,
floor
they are
plans.
given the layout, Sayok. This year, Ishrae has actually reduced their effort, and
Okay.
yeah, they
Have
have
you
been
given
So
the
we
using.
have
location as well?
given the we have
Yes.
yeah. I think everything is there.
Oh, okay, fine.
So if you have the layouts, so one huge step of your project has already been done. So that's a good thing. So now you should try to learn about heat load calculations. Uh, I don't know if you can alter the design or not. That's something.
Yes, you can. You can. You can alter the designs, but again, these are the questions that all the participants can ask to the jury. Again, on Monday we have a session with the jury. So, but as far as the competition goes, the history about it goes, so we were allowed to make little bit alterations in the drawings. So that wouldn't be a big problem. Only thing is that whatever is given, you have to keep that intact. Now, within that, if you can find something else that you can add, like Shayak in like this team in last year, they added the open air auditorium, right? So if you have a space, it's not going to be an auditorium, but I'm giving an example that if you have space and you have certain ideas that you can add to the drawing, so those things you can do definitely. And if you have some so those things, those are little bit alterations you can definitely do.
I would like to add
Can
something
one
also
one
in.
second, can
Yeah,
you
yeah.
please present the this year's problem statement so that we can have a look on it as well?
um
I'm stopping my share then.
no, hold on, I have to find it out, hold on.
Okay.
Okay, another thing is so it's so you guys this have this hospital HVAC design. It is similar to the another. It is similar to the hospital HVAC design which I had in when I participated in NSTC for the first time and I was in my first year as well. So
So we have a two-time NSDC champion amongst us. So Shayok is a two-time NSDC national champion.
That's wonderful.
Yeah.
Heavyweight champion.
Yes, he's a veteran actually in this champion, and uh, since he was a winner in 2021, I guess, uh,
yes.
he was also one of the major contributors, and he also helped us all along the way throughout this competition as well. And it was actually a great help in that aspect. So we have someone who is really who knows NSDC by its pulse.
Okay. So
So
the
I
thing
have
which I
shared
wanted
the
to
design thing,
tell.
yeah.
Yeah, so the thing which I wanted to tell that was the since you have got the floor plans, start by learning how to calculate the heat loads because that is an important thing. Start by learning how to calculate the heat loads and using we used HAP software. That does not mean that you have to use HAP software as well. There are other various softwares as well. And you can calculate without any software as well. There are some, I guess, some Excel sheets as well available in
Yeah,
the.
in fact, we are organizing one workshop on Tuesday, coming Tuesday, 29th of October. So there, one of our past winners from Kolkata will he will go take the participants through heat load calculations using the E20 Excel form that we have. So using software is easy because it saves a lot of time. But again, using that Excel file, which was the original, that the industry use majorly, you like they used to do it majorly with that form. So using if when you are doing it with that, you try to you have to take in a lot of factors which that our presenters has discussed today also. So the u values and everything, so those things you have to calculate and put it in the Excel form. So that way you although the software is not helping you much in doing the job faster, but you are learning a lot. So we have that workshop on Tuesday, so all the participants can join in that. And so yeah, and any other questions, like please unmute and ask the participants. You should be the one speaking more.
I think
Yeah.
the NSDC demands people bright minds, and I hope that people ask questions and get clarified on the topic as well. So don't hesitate, guys. We are here to
Yeah, you can
answer.
ask stupid questions as well.
Yeah, it's nothing. No question is a silly question or something. You don't need to fear that like what we'll think, because even we were in your situation. We were completely dumbfounded by what the problem statement was, and after months of preparation and brainstorming, we became the champions. So even we were in your shoes back, I think 1 year, more than 1 year. So ask.
Hello, sir.
Yes.
So you it's not important that you call us sir, because not sirs here.
Yeah, no, no.
Yeah, you
You
can
Fine.
tell us as
call
in
us
like you
Lord.
call us seniors.
Sir, actually, I wanted to ask that, like, it's our first time participating in NSTC competitions. So, like, everything is new for me and my teammates, like heat load calculation, duct design, and equipment selection, everything. So, I wanted to hear from you that if you have gotten some hospital to design HVAC system for that. So, what's your thinking on that? What are the parameters you can include in that? Just I want to hear that from your side. Like you all are winners for the NSDC, so that will be a good for all of us. Like in what perspective we have to think. As this is my question from.
No, I think there was a slide in your presentation. um Devjit, correct me if I mistook it for this year's. Was it for this year that you
We
gave some
actually
idea?
suggested, yes, we actually
Yes.
suggested for this year, yes.
Now, Shital, see, these workshops that we are organizing, you can after the at the end of it, it is up. It's you who have to do it. Right now, they have given you some suggestions. If you want, I think they can share the presentation also. You can go in details through
Yes,
that.
sir. Yes, sir. That would be much better for
Sequence
that.
that told, first you have to do the heat load calculation, then the duct designing and equipment selection, and then innovations. So that is the exact sequence in which you should follow, right? I
Yeah,
think
adding on to that, that like the basic thing is the the structure of it remains the same. Basically, you have to design a building. That is, first you understand this. The basic of it is you have some brick structure. You have to put soul in it. Understood? So
correct.
you
And
are
once you start
having
with the heat load and everything, you will, it's not a big deal. If you go through the PDF that was shared, the problem
Yes,
statement.
yes,
In fact,
sir.
I am also sharing my screen. So there exactly it is saying like what all things you need to put in the report. So just go through each of them. You have the drawing also. That is a big task that is already done. So all you have to do is just find out how to do a heat load, how to do the duct designing, how to do the airflow designing, airflow distribution also is comes along with the duct designing also. So those things you have to think, and yeah, it's just that you have to prepare one report, study the thing. Once you start, you will get a groove of it, and I think then you shouldn't have a
Yeah,
problem.
one thing I would like to add is that don't get too much overwhelmed with 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 the whole lot of things you have to do. Break it into small steps. The first step
Correct.
is calculating the heat load. To calculate the heat load, you need to first know how to calculate what is heat load, how what are the factors which influencing the heat load, and how to calculate it. And once you go there, then you will find there are many different things which you have to choose, such as the what are the things you would put in your each of the rooms, how to separate the floors into zones, what are the U values of the things which you will use for the walls and everything, what are the wattage factors for all the equipments which you will use. You will get that. You will go to there once you uh, break it into small steps, and once you try to go one step one by one, go over the steps, you will get to know of all the things you have to do it at that. Then it won't feel like a very big task. So start small and then move towards what you have to do.
Hello, Sanjeev. So I would like to ask you a quick question. Am I audible?
Yes, yes, audible.
Yeah, yeah, yeah.
So I just want to ask that you guys were the winners. So I want to ask the what do you exactly do other? I mean, apart from to make you apart from others participants. So like in the basis of you may have done some calculations or in the part of designing. What did you do different from the other participants that make you win it?
So there are, let me take up this question. So there are lots of points where Ishrae awards points to you. Okay. I think for our case, we had a couple of them. So let me go over them point wise. So first of all, since the problem statement was quite difficult last year, not giving the planning, if the planning is taken away from you, just imagine the workload that is there on a fourth year or a third year student who is just learning about like heat loads and stuff, and if he's asked to also take on the job of an architect and design, uh, it's a hell of a lot of task for like three students to do. So I think first of all, our design was very innovative. Um, uh, that was one of the things that we discussed amongst ourselves, that whatever we do, it should be five-star quality. It should not be like just a rectangular building and whatever, and we have everything in each of the floors and just get it done with. So there was a significant thought that went behind deciding on the layout. Okay, I think Ishrae awarded a lot of points for that. Secondly, uh, you know the presentation quality of presentation. So if you guys saw the presentation, I think every slide was informative, and every slide was had something to say, and you could take away something from every slide, right? So the presentation matters a lot. Okay, guys, if you are working, just working and calculating the heat load won't earn you the national champion. Okay, you guys need to present it in such a way that the person or the judges, the jury, is impressed by the way you are presenting. Just to give you an example, we were given 10 to 15 minutes, I think 10 minutes on the dot.
Yes.
Yes, 10 minutes to finish our presentation. So
Even I think 8 minutes or something.
yeah, I think 10 minutes, to be honest. 10 minutes was given to us to complete the presentation. Okay, and I'm not kidding you. We started on time and we completed on the dot on 10 minutes. So in corporate or a professional setting, these factors are important. You can't just take 1 hour for a presentation where only 10 minutes is assigned for you. So The presentation which was finally submitted to Ishrae, we went over each and every slide in such details, and we completed it with on the dot on 10 minutes. So the jury members who were present on the meeting that day, they were also impressed that we completed on time, and we also had answers to whatever questions they were asking. So since the design was like completely from our head, so they had a lot of questions on their. You can understand, right? So they went into the nitty gritty details, and we were so well prepared for each of their questions that we could answer all of them. I think that earned us a lot of points also. Third thing was the depth in which we prepared. So just focusing on the aesthetics is not all. Ultimately, this is a competition for engineers or budding engineers. You should have an engineering mind when you are choosing to participate in such an auspicious and such a important competition that happens across India, and you are aiming for the national championship award or a trophy. I think you can understand the weightage of the competition itself. So as engineers, you should have an engineering mind. You should be, you might not have all the answers to the questions that the jury is asking, but you should be quick-witted. You should be able to answer this on the spot. I think Devjit and Shayok can add on to these 3 points, but I think that covers the essence of like what we did different.
So yeah, thanks, Orgo. And to like brief the whole walk through a little bit, it's more on for NSDC purpose. First of all, you need to have a technical background in terms of that what you are preparing the slides upon. Okay, so you need to have a holistic view of the whole problem. It's not like you are tackling one side of it, but the cost is getting higher, or you are making it so cost efficient that the facilities is getting compromised or something like that. So you have to come across with each and every point that is being given there. So in the I think in the brochure you are having some 9 or 10 points to be captured in your presentation. So you just try to tackle as many points as you can, then that would earn you more points. It's kind of like that. Then the second point is what Orgo already talked about, is it's not about that you are working, you're working maybe late nights for the project, but you cannot, present it properly. For like I think you already know, or you already have come across with some teachers or some students who are very good at what they are doing, but they cannot teach some people. So you need to have that kind of what to call it, kind of presentation skills or something like that. So you need to show that what you have done. It's not like that you have worked on maybe 2 months on it, then you cannot show, because ultimately you would get a 15-minute slot at max. So in that 15-minute slots, you have to make every second count there. And the judges who are present there, you have to make sure that they are getting something from the slides at every minute. And the last thing what I would say is that there is a tendency in generally in undergrads that we try to bluff on certain things, that we certain things we do not understand, but we are still putting it in. That cannot help you in the long run. So because the jury members who are present there at the time of your presentation, they are maybe even working on that certain projects which you are putting in there. For example, back in our time at the presentation, I have like we have introduced the concept of seawater cooling. I don't recall his name, but there was one jury member who actually had worked on this particular seawater cooling technology. So you can understand that if we have bluffed on the technology that this can be done, this cannot be done, he could have easily caught us that these people do not know about the stuff, but they are just putting it in for the filling section. So you cannot do it in that way. And another point is,
He
in
actually asked us some questions which
yeah, yeah,
we
which we
couldn't even
tackled, yeah,
answer that time because we hadn't even thought about those things.
yeah, certain points were even in the
So
hackathon was we also participated in the hackathon. I think in hackathon there was similar situations. So yeah, so that is another very important key parameters which you need to focus on. And final thing is like this, when people join in a kind of this technological competition or something like that, they keep the technology at the peak or they keep the technology at the top, but they forgot about the business perspective of it. So you have to keep that in mind as well. So to be very honest, my suggestion for a perfect slide would be, first of all, you have all the technological parameters or all the technological findings inside. Second point is, you have to keep the business perspective as well. For example, if someone is making a hospital, they need to make profit out of it. They have to pay the nurses. If you're using up the money in the HVAC system only, you cannot pay or you cannot afford more doctors or more nurses, so the hospital cannot prosper. Or you have to charge poor people more and more. So that is not the way. So as an engineer, you have to think on that point as well. Third point would be, from my side, is obviously the presentation skills. In the presentation skills, I would like to mention about that the time boundness of your presentation. So you have to keep in mind that I am having this maybe 10 or 15 minutes of slot. So in this 15 minutes of slot, I can accommodate hardly 10 slides or hardly 8 slides. So that you have to keep in mind as well. You cannot like go on forever. Your report can be very niche and perfect in its way, state of the art. But if you are not presenting it in time, that is a knockdown for you guys. And last thing is, try to maintain a good aesthetics. I know this is not as important as the other points, but this actually helps because like try to maintain minimal number of writings in your presentation. If you're writing something, make it make it seen. Or you if you're having multiple fonts, so for example, on one slide or on one page you are having this certain maybe normal your Times New Roman font, or in other slide you are having this Helvetica font or something like that. So this things doesn't look that good, so people would lose their focus on your slide. So you have to keep people attracted to your slides as well. So that is something. And some color contrast, color themes, you have to like if you're having some text or something, you should use high contrast color backgrounds and text. So these are some few things here and there, but majorly this 4 points you need to tackle to be good at your I don't know if you would win or something, but I think you would be proud of your presentation if these all points are covered. And last thing is, you have to believe what you are presenting. So if you are doubting your presentation, that okay, I have filled in these details, but I don't know if it's that important or something like that, you wouldn't have that much confidence in it. So confidence is the key. Yeah. So that's all from my side.
Thank you. Yeah, Shahid, hello.
I think there is another question in the chat box. Yes,
Someone
Muhammad
was
Kamal,
someone
I think.
speaking.
Yes, sir. I was speaking. I was giving a comment, sir.
Okay,
Okay.
question. But I have shared my the flyer for the next session, which is on Monday. So if you have not registered, please scan the QR code and you can register. Sorry, go ahead, Yashraj, with your question, and then we will take the questions in the chat.
Okay, thank you very much. Sir, I was asking that while designing the overall structure of the hospital, like what direction we should consider our rooms should be facing, like to the environment.
What direction? I mean, are you asking about north, south, east, west?
Yes, sir. What like our
Yes.
window?
So there was a slide, I think, where I explained you the layout of the rooms, right? in that slide only, I think if you had paid attention, there was a uh, east written on the lower left side of the slide, right? In the east lower corner, in the left corner of the slide. So we planned that the hotel would face east because it was a east facing the sea. Also, there was another thought process behind putting that was we
Like,
wanted least surface area exposed to the sun. That is also an important consideration. So when you think about the day, the maximum heat that comes into the building from sun rays is during, can anyone say on which side of the building? It's on the west side, right?
Yes, sir.
Yes. So on the west side of the building, the maximum amount of sunlight a building will be able to receive. So we wanted minimum surface of the building. That's why we made the west side of the building area smaller than the surface area of the walls on the eastern side. Okay, that is also a small tidbit for you guys. Okay, so if you are allowed to change the direction of the hotel, I think you can keep this in mind.
Okay, well,
Yeah, and actually, in the AutoCAD drawing, the direction might have been given. So just have a check it like once again. And if it's not given, if you have to choose, then the best thing to do is follow the Ishrae handbook. So Ishrae handbook you will need while doing the heat load calculation. And when you go through certain tables that are there, so there you will get to see that for a given location, for a given city, or for a given place, what is the distribution of the sunlight throughout the day, and what time is it maximum, and all of that. So you can plan accordingly. Now again, that will be covered in the heat load calculation session, so you can join that as well. But these things are there in the Ishrae handbook, the data. And also I'm sure in the AutoCAD drawing, the direction must have been given. Okay, so Shayak, if you want to take the next question that was there in the chat box.
Yeah, so this question is like about choosing the materials. Yeah, I think you can choose the materials as you wish, keeping in mind the U values of the components and the heat infiltrations due to them.
And also
So
the cost, very important.
yeah, also the cost. That is a also huge factor actually. So you can choose the materials as you wish. You will get the U values of each of those materials from the handbook, and you can choose as you wish. Any other questions?
Okay, Mohammed Kamar is saying the directions are given in the bottom left corner of the layout. Yeah, like I said, it must be there in the AutoCAD already. Jyoti Ranjan, answer etc. Join. Okay, so yeah, 20th and 29th, please join both of them. Those both are very important. Just like this one, I think this one was a very insightful one, and thank you guys. I think you did a wonderful job, and you have explained excellently, I would say. Since there are no more questions, we will try to close this session. But I'd like to formally thank Orgodip, Shayok, and Devjit for taking all the trouble and joining us and guiding all the students. So it was really wonderful that you have joined, and you have agreed to help our students this year. We will look forward if we need another session with you, maybe this year we will again maybe ask you to help us out with that. But till then, until next time, see you all. Thank you to all the participants for joining this evening, and make sure you are joining on Monday and Tuesday evenings also. I have shared the registration this thing for Monday, and this is for Tuesday. So if you want to get here also, so we will see you then. So thank you all. If you want, I'll stay back for 5 more minutes. So if you want to scan this QR code, you can. But see you all again. So thank you. That's all from our side.